again to the August Scottish Blockchain Meetup. It's fantastic to see everyone here again tonight. Amazing turnout once again. I think I said last month how it was the most popular ever. We've surpassed that again, so thanks very much to everyone. I think there was about 164 registered, so by far the most popular. Great to see it continue to grow, so thanks everyone again. Regulars and first-timers, always welcome. So tonight, thanks to Bill, the guys at Edinburgh Napier for hosting us. It's great to be here, always looking for new venues, and it's a fantastic space, so thanks very much for your hospitality tonight. And again, the guys at Product Forge for the live stream and continued support on the video, so thanks again. So tonight, just before we get started, just to let you guys know what's coming up, ScotChain 17. So some of you will be aware of ScotChain last year. It was an all-day event focused on blockchain, obviously, big success. It's going to be October 13th, RBS Cockburn again. That's the website if you want to check it out. And I don't think the content's up yet. There's still a few speakers to be announced, but if you go on that website, it'll give you an idea of all the details from last year. It'll give you an idea of what's to come, and we'll get that updated as soon as possible. So I won't keep you too much longer. On to tonight, we've got Professor Bill Buchanan, OBE, a lot of you will know, home here at the Napier Uni, and James Littlejohn, who's going to continue a talk that he started back in April, I think it was, at the Blockchain Meetup, and that's on lknhealth.org. So we'll start off with James. I'll hand you over, and hope you have a great night. Cheers.
Thank you very much, Daryl, for that introduction, and it's good to be back so recently because I have really been not at any meetups since April. So, and thanks, Bill, for chairing the platform. So, no, it's changed here, but not on the. Anyway, Guten Tag. Any German speakers in? One. So on Tuesday night, I was in Berlin hosting or co-hosting a thing called the Science Blockchain Meetup. And it's a loose collaboration around a project called the Living Knowledge Network. So I was just going to show you lkn.foundation. So this is this big grand vision to keep all science on planet Earth honest and truthful. And what I'm going to talk about tonight is one particular use case problem. Hopefully I'm going to set up all the problems that Bill is going to solve in his talk. So our Blockchain for Science meetup had 5 people, the first event at the start of the year, and then the last one we had 20, and then this week we had 40. So the very first time I came to the Bitcoin meetup in Edinburgh, I think it was 3 of us above a bar, and so it's great. So I expect most of you weren't at building a transnational health service on the blockchain. 1 or 2 I think were, but more or less. So I thought I'd just do a very, very quick recap on what that was all about. So that was the intro to the talk. But I started by saying, or giving a definition of health, and instantly most people think of healthcare. Hospitals and disease, whereas for me it's a much broader term. It means how healthy is everything living on planet Earth. Humans, animals, the environment, plants. And so this was a simple Bitcoin mantra that regardless of where you're born on planet Earth, you should have the right to contribute and extract the best health knowledge out of the network. And because we've now got this blockchain, it should be immutable evidence. So that was the grand, and there's another hour, and you can watch the video online of all the philosophy behind that, and I'll leave you to do that. But tonight I just want to take one use case, and we call it the LKN Health. But what is the Living Knowledge Network? I asked it to the scientists that had turned up in Berlin on Tuesday. Who understands what the Living Knowledge Network stands for? Put your hand up. And Oh, great. Yes, we've got 2. No one had an idea. I mean, the 2 organizers did. And I put my hand halfway up. Alan knows it all because he put his hand full up, but I said I think I know half of it, but it's an ongoing collaboration. But what it should do, this foundation, is facilitate open collaboration around creating the protocol itself. Its goal is to validate the science, how truthful it is, ultimately issue a knowledge token. And a knowledge token is a currency, but not a monetary currency. So this project is simply a starting point to learn and share learning. So I put the link into the demos I probably showed at the last talk. And if any of you were there, you'll see how clunky they were, because I had to take a particular open source wearable, download a log file, then upload that log file to MadeSafe, and then put it through Ethereum smart contracts, and then do the same for scientists, and somehow they marry together, and we had some graph visualization. And today all I have to do is go to my tablet here, and we chose a different brand of wearable. It's called a MAU, and we built our own iOS app, that Android one coming in the next few weeks, which streams in real time the heart rate to our own app, which puts it to my own personal crypto storage network in the cloud. Because I'm traveling at the moment, it goes to MongoDB with a BigChainDB interface. But if I was at home, it would stream to my MadeSafe account. But I can basically put that data to any crypto storage platform that the community would want to do it. So we've just got one simple variable. We've ignored accelerometer and temperature and all these other cool features. So it's cool. Real life demo data throwing to the crypto network. But now we have to ask some questions. So there's actually 2 people live on the network and probably another 4 off on board. So what questions do we want to ask of science? Well, the very first question is, what is the average heart rate? And of course, it seems a simple question, but the statisticians instantly go, did you mean mean, mode, or median? Well, the GAT standard that we're using is beats per minute, but it could be 1 minute, 10 minutes, that day, all days, every day I've worn the wearable, after swimming, before swimming. And then maybe the median is not the most appropriate variable to investigate the heart. Maybe it's the median, the mode. So right now, I think Simone is in the audience, a data scientist. He is. He's giving us some computational models, and we'll run those across the network. And then we have this, so we got these analytics back to ourselves. Then the next phase is to do them across the network. But how can I trust all you guys, especially Simone, right? So of course the answers need to be visualized, and I think the role of the Living Knowledge Network is to get the entrepreneurs in the audience and the data visualization people to do that. So that's all that's saying. Now, setting up builds problems. So we have the wearable, and it's streaming to an app. How do we know that the connection between the wearable and the app is secure? I can tell you right now, it's not. And I know from Bill's talks, he could have intervened on the Bluetooth connection. And so hopefully Bill can give us some solutions there. I know he can. The other one is saying, how do I know I'm wearing it? I could have given it to Bill. I think that's a harder problem. I think we'll come back to that. And of course, I could have created a software program that mimics the data format and just fired it to my own account. So these are open questions. We're working on techniques to solve that, but hopefully Bill's going to give us some foundations for that. We put it to an iOS app. How do we know that iOS app is the app you downloaded from the App Store? How do we know that your particular version has got the right averaging? Right now it speaks to my MadeSafe account. Well, maybe that gets intervened. Or maybe the BigChainDB, the DigitalOcean droplet gets compromised. So these are all problems, but now that we've got a flow of data, then let's put solutions in and test them and share those results to the community. So we got our data, and someone is now giving us those computations. And this was the talk that was given on Tuesday night. It was by Christian, and I will not do his surname because I forget it. But Christian is an employee of Ethereum and is in charge of the Solidity smart contracting language. And he's also a sort of co-founder in this thing called TrueBits. And his talk was, and I think it was entitled about validity of scientific computations. And so what he basically said that TrueBits was a short-term solution to guarantee that the computation was honest. In the long run, he said, we will use zero-knowledge proofs. Again, I think Bill's going to enlighten us on those. But these are so expensive in Ethereum right now that you wouldn't use them practically because of the economics and plus the inefficiency. So what would TrueBits give us pretty much now if we used it? So someone brings a Python script that says, I can give you an average heart rate. And that's basically adding up all the digits and dividing by how many there is. So let's say he puts a test that says there's 10 digits, 72, 70, 70, whatever. And he sends us the data, and we divide by 10, and we would have to get the average of 72 or whatever. But what TrueBits would allow us to do is like we would all be given those computations, and you put a sort of a ether at stake. And then at random, it chooses particular instances to see what the code's doing in the memory. And if all the participants, there was 10 of us in the experiment, authored the code as the way that it was downloaded from Simone, then we would get proof that this algorithm is actually averaging in the sense that we would all expect it to. So now that it has a valid status, we can all download it into the iOS app and thus get bulletproof validation that the statistics are what it does. And then we're going into the living knowledge network, which in 15 minutes is going to be impossible. So I just prompt you to the LKN. So I think that's just, yeah. So this is working. We got personal statistics, network statistics. Some are like predicting heart rates. We find a statistical valid machine learning algorithm for that. So the idea of this last part is we through what we call a knowledge token. And again, I'm not fully sure what that means, but it means that all the science and all the data and all the computation, as far as we know, have been validated to be honest and actually happened. And in terms of the scientific method, if you were to repeat this across the network tomorrow, the day after, the same answers would come out of the network. And so everyone that's involved in that collaboration would be issued a share of this knowledge token. And the unknown thing is, like Bitcoin, would that knowledge token at some point in the future be worth a peg to a monetary currency? We don't know, but that's the way. So right now there's a loose collaboration across planet Earth, but some of it's thinking, some are scientists, researchers, software engineers. If you want to join, there's no rules. We've just put forward this week what we call federated protocol building. So there'll be a workflow. If you have any ideas of what would be needed for this living knowledge network to contribute it, put a testing and validation and acceptance, just like SegWit2 and stuff, so that will become part of the cake. Yep. This fabric is being built out. We're now bringing it into the science realm. Let's get the hands and health back into our own hands. The evidence will come from the algorithms in the network, and everyone is free to participate. So that's me, Bill. Over to you.
There's another microphone somewhere. Right, okay, so I'm going to follow that up. So we're very happy to be working with James for a long time and can really see his vision. Does anybody know why I've brought the lamp along with me? Don't steal it. Why have I brought the lamp along with me? I'm a fan of the 70s, yeah. I was born in the 60s, but I'm probably a fan of Slade and Sweet and things like that. Anybody an idea? Chaos, that's exactly right.
I don't know what.
Just trying to remember this is one of the best random number generators that you can actually get. Yeah, just a few. And I think it's Cloudflare. Cloudflare have a really cool office in the US just now that has a whole bank of these, and it's generating the random numbers for, I think, 10% of the traffic that's available on the internet. So I brought that along, so if you just point your camera to it and take a little picture, then hopefully you can get a random number from there. And I've got my geeky t-shirt. Okay, don't tell anybody, but it's not in, is it, what does it say on the dollar? So I've got in crypto we trust. Okay, but don't tell anybody that we're selling the t-shirts outside, so just get ready for them. Right, so I'm going to kind of take a random walk, okay? I think we all I love crypto with a vengeance. If you ask my wife, you'll know that I sit and do crypto a lot. And I break and I do every type of crypto, and I just cannot get enough of crypto. I just adore it. So it's the area that I've stuck with longest, which is pretty good from an academic, and that's the good thing. So hopefully I can stick with it for a lot longer. But what I think we're not doing, business people guess what we're doing here, but the citizens still can't get over the hype. It's going to go away. Bitcoins are going to go away. It's going to burst. Blockchain is going to go away. It's all hype, things like that. So we need to articulate much more to our citizens about what the amazing thing is. We need to be telling them that that was the old life and this is the new life, hopefully. Or maybe it will burst and we'll have to all go back to teach networking again. And that's good. That's pretty fun. Okay, so I'm going to talk about the future just now, some of the problems that I've had, and a bit about ZKP. I'm going to do a bit of mathematics, okay? You've had a long day at work. I'm actually going to make your life really difficult and do some discrete logarithms because you're in the home of John Napier. Can you hear him? Can you hear him? Yeah. He was a crazy man, and I won't go into why he did what he did to do with the rise of the papal religion, all that kind of thing. He was a very strong Protestant, and he saw a logarithmic rise in things that were happening. So he was a strange person, but a genius. So as you're in the home of John Napier, one of the finest Edinburgh sons that has ever existed, as good as Maxwell and all these other ones. You do know where is Maxwell in Edinburgh? Where would you find them? St Andrews School, that's right. Every time I go past them, I say, thank you for the PhD. You did well. I got my PhD around Maxwell's equations. That was a long time ago. Okay, so I'm going to put up a disclaimer. Okay, this is my disclaimer. Okay, basically it works. Okay, if anybody asks you about crypto, I was asked today by a company, what's the difference? I'd written an article for this big company and said, what's the difference between encryption and cryptography? I go, I don't know. Crypto is kind of lots of things, and encryption, what you kind of tell people that you do, kind of thing. It kind of doesn't spook them as much. So I couldn't quite explain the difference. I said, just put encryption down, it's fine. So if you read a story from me, from a big company, then you'll find that it's all got encryption where it should have been cryptography. So please don't excuse that. Okay, so this is my disclaimer, okay? I don't know if you heard, but there's been another initial coin offering hack Sunday, and there was one kind of last week, and there was one before that, and stuff like that. They go, it's all right. It's only 0.1% of all the initial coin offerings. It's okay. Do you know that the CEO Anybody know the company? I can't remember off the top of my head. Anybody know the company that was hacked? Was it Enigma? The CEO of Enigma, hopefully he's not watching, the CEO of Enigma was on IBeanPwn. Do you know that one? You know that site? And he used the same password that was this is alleged. I read it somewhere that he used the same password, Scott, that was on IBeanPwn. They got into his account, and you go, what? You didn't have two-factor authentication? You're selling Ether coins and crypto, and people are just gunning for you, and you've used the same password as you did 5 years ago, and it kind of, you go, oh, no, you're being negligent here. So here we go. It works, 100%. We crack AES in 30 minutes. Owen's not here, is he? He's on holiday. Crack it through side channel, but that's another story. But generally, AES kind of works great until it doesn't, okay? That's the first disclaimer. Second is it works great as long as nobody makes a mistake, like leaving their password on IBeanPwn. Encryption works great unless something goes wrong, okay? And encryption works great as long as everything else works right, okay? I'll get you to do a Venn diagram of that.
Sounds like a phrase from Murphy's Law.
Oh yeah. Everybody who's attended this lecture has approved this when you signed up online to Meetup. That was the disclaimer that it said, you read your terms and conditions? That's good. Okay, so that's it. So I'll give you a bit of background, okay? We're lucky enough to deal with some amazing geniuses. We're a kind of little factory of geniuses. That's what universities are all about. They take the raw. I remember Jamie a long time ago, didn't know where he was going, he didn't know what he wanted to do and stuff like that, and he's an amazing world-leading executive now in 40 Terficken Street. Codebase wasn't good enough, so he decided to go up the road to 40 Terficken Street on the 6th floor. I feel so privileged to get the lift up to floor 6. Right, okay. Is it okay if I come in? That's right. So, he's now leading ZoneFox. What I love is this. I hope he doesn't mind me saying it. I just love that. Is he Tintin? No. So and this was our second spin out, Symphonic. Oh, they are going places like anything. So that's Symphonic. They are in Codebase. We had three companies in Codebase, and we thought we were doing really well. And then one of them went left and went up in a bit. So we've still got 2 left in there, but they'll probably outgrow it, and they'll be in Terficken Street at floor 5. I could spend half my life in there. That'd be really good. And then these guys here, this is Sign Forensics, and they're going places too. Really disrupting, changing. We don't do things by half. We don't want a little bit of research. These guys are changing law enforcement, hopefully, for the good. And I promise I will not mention my book, okay? I've been told not to mention my book, okay? I will not mention my book in this presentation. Not that it's on Amazon Prime and ready within 2 weeks, and it's under £50. I said, you can't sell it for £51 to students. No way. $49.99, okay? I will not talk about my book today, okay? It will not be talked about. I shall not talk about it. It's gone, okay? So I was told not to mention my book for $49.99 on Amazon Prime, and so I didn't do it. So that's very good. So I'll give you a bit of background, and I'll tell you why I came into this area and why I just adore blockchain and Bitcoin and cryptocurrencies and so on. Okay? Well, I think it's a bit like this. This was created 100 years ago. It's the machine. They created, mankind was worshipping the machine. And I think we're here. We're here again, and basically we're working the machine, but the machine is now not metal, it's cyber, it's software. We worship our machine, which is the clouds. Okay? It's the greatest invention ever. If you can call it an invention, it's the most wonderful thing that has ever came along that's been built so quickly. Definitely it's the best thing that's happened since the transistor. And this is where we are. We're really building, well, we kind of built a machine and it's rubbish. It is abysmal. It is a place for horrible people to please. It's a place for horrible people to exist. It's a place with bad cyber criminals and it's rubbish. It's garbage. So we have the opportunity to rebuild it with a new world. That's an amazing new thing that we could do. And somebody told me, who was it? Don't mention GDPR. Is it you? Don't mention GDPR. Whatever you do, don't mention. So I'm going to mention GDPR, okay? Because GDPR kind of makes it a lot more painful. It's a lot more painful. Where will I start? Where do you want me to start? Here, okay? We're all going to have to learn, I'll say cryptography, but encryption, okay? Your CEO has no excuse anymore. No excuse. If they get pinpointed on Sky TV for not encrypting something that you said, then they have no excuse at all. So make sure you tell your CEO about cryptography and public key encryption. I'll come back on to that a little bit later. And basically, pseudo-anonymity, I can't even say the word, hiding things about people. I really don't think that many of us know what that really means and how to design systems and architect them. I think we're a million miles from there, and I really worry that people just think, oh, we'll just make sure it's encrypted. But where's your keys? I don't know. And your SSH to the cloud, do you know who's looking after that? I don't know. So I really don't think the industry knows. And then we're going to have to be a lot smarter in responding and telling people, oh, we didn't use bcrypt, we used a Caesar code. We thought that was going to be secure. There was a terrorist recently who did Caesar code. He didn't trust Western crypto and he went and used a Caesar code. Even though they encrypted the Excel spreadsheet with an encryption key, he refused to use Western cryptography for his secret, so he used a Caesar code in terms, and the police were looking at, oh, I just can't get this one. What could it be? Is it Des? No, I said, why don't you try Caesar? No, they'll never think of that one. And they found it was a Caesar code that he was using to store his information. And then, come in. It's okay. And then, most scary of all, is that you're going to have to get the citizens involved. Me, you, everybody, we're all citizens. We're going to have a role. I want my data back, and I want it now, and I want you to protect it, and I want to know what you're doing with it. If it's my blood pressure, I don't want a smoking company to be analysing that. Cancer research, good on them. So we should have some way to control, and I don't think we're there yet by a million miles. So I talked about GDPR, so you can tick that one off. I hope everybody knows there's going to be a coursework after this. I'm an academic, we're academics. There's going to be a lot of maths and a lot of testing, stuff like that. So I hope you've had a few beers and everything's fine. Does anybody who know who that is? No. Oh. Who? Stallman, not good to answer. Anybody know who that is? Ken? Ken who? Ken? No. C++, Unix, what is it? Who's it? Say it again. No? No? What? Who? Who? Is he talking Dutch? It's Danish.
Is that C, the author of C? Is,
No, Kennigan and Ritchie. Babbage, no. Brian Carrier's a good answer. Is it? Very good answer? No? Who? Excellent. And who was he? You looked up in Wikipedia, you looked on Google, did you? No, did you take a picture? Okay, does anybody know who he was? I met him. I had lunch with him. I go, hello. What? Yeah? Postal.
Postal was one of the guys who designed IP, wasn't he? Who came up with Postal's law.
He was an editor. He was an editor. There he's there. Okay. I met him. Oh my God. I met the guy who edited the RFC on TCP IP. And you go, wow, isn't that fantastic? Well, he was an editor. DARPA really wrote it. But that was that guy. And he wrote that. I have read that. Has anybody here read that? No? That's really sad. I've read that. And I've read that one too. And those two things changed the world. And Ethernet. And Xerox. Don't tell Steve Jobs that. Xerox kind of changed the world because of Ethernet and GUI and the mouse and so on. So he wrote those two things. And really, that is old. That is history. That is the old way of doing things. It got us where we are, but it can't really go forward. Oh, sorry about the X. And who's that? I'll give you a clue. H-A-L, which is one letter removed from IBM. I don't know if you knew that.
HAL.
How? That's how. How?
Space Odyssey, 2001.
Oh yeah, no, not that how. That was a computer. What was that how? How Finney. Okay, do you know where Hal Finney was involved? He did the first Bitcoin transaction. He was involved by a strange guy.
You make the first Bitcoin transaction with Satoshi Nakamoto, no?
Yeah, so there you go. So who's that? So, who is that? There is an interview with him that's saying it's nothing to do with me. So if you find him, I'm his best friend, okay? I'll buy him a beer if he wants, because he's kind of got a lot of money. The guy signed the eighth transaction. This guy was doing lots of mining. You know, it was some crazy amount, like 100 bitcoins. You know how much 100 bitcoins is worth? Now, do you know where we are with mining, roughly? Was it for the? Oh yeah, no, for the reward. I'll come back on. 12 and a half. Okay, keeps halving. When this guy did it, it was 100 bitcoins. You just get ka-ching, ka-ching, ka-ching. I'll mine it. Oh, ching. What do you want to mine? No, I'm mining. It's okay. So there's a lot of money waiting for this guy. If you can get that shouldn't have came up there. That was a mistake, and I'm sure he's Japanese or okay. That's a bit worrying. So sorry about that. Okay, this is the old world. Okay. I'm going to tell you a story. It's got nothing to do with blockchain and Bitcoin, but I thought I'd tell you anyway because it really opened my eyes. So that's what a polling place looks like. Oh my God, that's it. And then in Scotland and the UK, they have crazy people that count votes, and you get a pencil. I don't know if you've ever done that. Maybe it's just me. Maybe just make me do it with a pencil and a bit of paper. But they stick it in a van. That is really secure, isn't it? And then they drive it across town. Really secure, isn't it? And then they chuck it on desks, and then they count the votes. And they go, I don't like that. So they count it again, they get a completely different result. You go, let's count it again. And they get a completely different, and someone else wins, and they say, that's it, we're finished. Please don't quote me on that one, okay? It did happen in Scotland. I think there was one case that they kept voting until one guy won, and they said, that's it. You go, what? They won, somebody won 2, and then someone else won 1, and then they stopped it. So I'm not implying anything there. I'm a crypto professor, I'm not an economist, luckily. And I saw this, and I thought, this really typifies to me where we are in the world. Kids just now, I don't know if you have kids, I've had kids, but but somebody received a 6-page double-sided form to fill in for their kids, and then you go, what? You're joking. In this day and age, you get your kids to take home a 6-page form that you fill in and take it to school, and then somebody goes and codes it into an electronic format and sticks it in the bin, and you go, what kind of century is this? So I just wondered about that. So you're going, where is he going with this? So it happened in the Scottish independence referendum. I won't say how I voted, but something happened around that time that, was it? I'll just say that if I voted now, I'd probably vote differently. See, you can't, see the logic. See, you're all saying, no, yeah, it's that way, but oh, no. So it happened in the Scottish independence referendum, probably the greatest debate that I've ever seen, and everybody, I've got to be there. I know my vote won't count that much, but I've got to vote and stuff like that. So I went there. Does anybody know where that is? Juniper Green, okay? Don't ask me the name of the church. Juniper Green Church, I suppose. So I went there, and I was going, oh yeah, here we go. I have my bit paper. I have this bit paper that came through my letterbox that the postman gave to me, and I grabbed it, and I said, that's mine, okay? So I went along, and I said, all right, there you go, I'm ready to vote with my wife and stuff like that. And I said, I come from there. Okay, that's a Ford Sierra, that's an old picture. But that's the railway inn, I think, in Juniper Green. I live in Juniper Green. Okay, I'm a very proud Juniper Green citizen, and I'm ready to vote. And they said, no, you're not, you come from there. Where's that? Leith. I go, no, I come from here, Juniper Green. I'm a citizen. I pay my taxes. I take my bins out, and I take them back in Juniper Green. And they said, no, you don't, you live here. I go, maybe I do. Maybe this has been a dream. And I think I'm living in Juniper Green, but I'm actually in Leith. So they wouldn't let me vote. And you go, oh, I was crying, I've got to vote and stuff. So I got in a big debate on the phone with somebody, I don't know who, hopefully they're not here. But I was very polite, so I go, I would like to vote, please. I come from Juniper Green, I'm a professor, I want to vote. Please let me vote now, please. I won't get annoyed. I'll phone up Nicola if you need to, I don't know. Just let me vote. No. And they go, no, you stay in Leith. And I go, oh, well, maybe my son, he lives in Leith. I know that. And I just came back and go, oh, yeah, that's what's happened. I go, what? I made the mistake of calling him the same as me. Okay, he's Billy. I'm Billy. William, you know me, Bill. So I made the mistake. Don't do it with your own kids, okay? Don't call them the same name as you, okay? Or you won't be able to vote in the next independence referendum, which I know you'll be an old person by that time, but that's another story. So I go, oh, surely not, that when he went to go in Leith, they would just take my identity and stick him in Leith. You go, oh yeah, that's what's happened. It's all right. Just pass me on to the person who's there, and we'll make it okay for you. You go, what? No public key encryption involved or multi-factor authentication here? No, it's all right. You do know that this is an insecure method that I'm talking to you on. Oh, it's all right, it's okay. Just hand me on. Yeah, it's okay. Yeah, just go in and vote. Yeah, we'll just stand your name to the bottom of the pile. But what kind of world is this when I teach cryptography to my students and I got told I live in Leith where I don't. Okay, so that really changed my opinion of the world. And then I get this in the post just the other week there. I don't know if you can see that, but it says, "Dear occupier, do you want to vote?" And you go, no. It's too soon. Dear occupier, if you kind of want to vote, then tell us who's in your house. No, you tell us who's in our house. You should know. We pay our taxes. We put our bins out. Oh, I teach sometimes, and I write research papers, and you call me dear occupier. And he goes, yeah, you can use SMS if you want, and what? And you can use email and stuff like that. So you see, the state has no idea that I really exist, do they? Every time I go to the NHS, I have to give them my email address. Oh, well, that's a bit far. But every time I need to give them my telephone number and stuff like that. So it's a really strange world that we live in. Okay, so I was very lucky. So I don't know if you've heard. I kind of heard, and I kind of dropped through the floor. But I kind of got some nice letters. I got one from the EPSRC to say, good for you, Bill. And I said, well, what about that last grant that I didn't get? I got 3 6s, 6 out of 6, 6 out of 6, and 6 out of 6. And I didn't get the grant. Okay, but that's fine. So I got some nice letters, and I got a letter from, oh boy, goodness, from Nicola. Oh, yes. So Nicola, yeah, it's typed, it's not written. I appreciate that. She's a very busy person. But she did sign it, and she did say, Dear William, which was good, better than Dear Occupier. Dear Occupier of OBE. So I'm not sure the Theresa May one. There was one before with Theresa May, but I got one from Ruth Davidson, which I put on Twitter. And then I said, maybe I shouldn't do that. So I took that one off. So if anybody wants to see the Ruth Davidson, it was a really nice one, handwritten and not Dear Occupier. And I got some nice letters. So I think you do know there's a Lord Lieutenant in Edinburgh. There is. Yeah. So if you've got any questions about the Queen, he's the guy to go and see. He wrote me a nice letter. I went and tweeted this one. And I said, oh, I've put my address. Okay, so the second one, I've got that over it, so you don't see my actual address. So I got that one, and then you know that I do Bob and Alice. Oh, there you go. That's good, eh? Cool, Bill. You're like a Rolling Stone! Exclamation mark. No, you're like a Rolling Stone. And me with a Nobel Prize. Don't let it get you down. Let's jam the world. I go, yes. I'm there. I'm jamming with Bob Dylan. Is that a fake or not? Is that a fake? Did Bob really send me a letter to say, let's have a jam? I'll leave you with that one. And then I'll go, oh my God, it can't get any better. Hello, my dear. And you warm to the person. That's not Dear Occupier. That's cold. This is hello, my dear. Okay? Very affectionate. So only the deputy of the UN, the deputy secretary of the UN, wrote me, who lives in Leith, a letter that says, there you go, you can have 1 million. Is that 1 billion or 1 million? I don't know. I think it's kind of 1.2 million, okay, from the Secretary General of the UN, because my government has been negligent. No. No way has our government been negligent in the last year or so. I don't think so. I won't say which government because we've got 2, so it could be. So that's really good. Because of that, he's going to send me an ATM card. And I'll get my, imagine going to the RBS, go, oh, there we go. Go away. 1.2 million, that's a lot. I don't think ATM machines run to the 1.2 million, but I may be wrong, maybe there is. Okay, and what do you say, he doesn't exist? Of course he exists. Of course he exists. There he's there, okay. So that guy there, oh, sorry. He sent me an email to say that I was getting 1.5 million. So I think it's really good. Okay, that's the world that we have created. that wonderful world of the internet that we can't tell if it's right or wrong. So what's that? Football, yes, I know. What's that? What teams are playing there? Crystal Palace, excellent. Let's have a boogie here. And who's that? Juventus? No. A lot less glamorous than Juventus. Huddersfield. Okay? And you go, where's he going with this one? I was reading my Sunday Post, and this came to mind. I don't know if you remember it, but it was kind of crazy. Hull won 3-0 against Crystal Palace, and it was quite a shock at the time. So I was reading my Sunday Post, and this came up. So close, David. Okay, it's difficult to see from there, but this basically says that Huddersfield were winning 2-0, and the bet was 1,000 to 1 for Huddersfield to win. Okay, and there's only 15 minutes to go. You decide now whether you take that bet. So who takes the bet? Everybody. Yes, I'll put my house on that. They're winning 2-0, 15 minutes to go. They're giving me 100 to 1, and I'll go for that. I'll put £1,000 on, and I'll get a million, 10,000, and I'll get $1 million. You go for it, okay? And then they said, "Oh no, it's a mistake." You what? I put the bet on in true faith, and you took my money, bookie. You took my money, and it was online, and I took a screenshot just in case. I took a screenshot for the Sunday Post, and there it's there. And they go, no, there's a bug in the software. So who thinks the bookies are right here? Are you going to put your hand up, Andrew? No. And who thinks the bookies are wrong? Yeah, of course they're wrong. They took it good faith. And to me, that's a good example of a smart contract. There should have been a smart contract between the person who did the bet and the bookies to say, if I put £10 on, you can be negligent by saying it's 100 to 1, but you will have to pay. And the instant that I get the referee to blow the whistle and somebody agrees, then I get the money. To me, that is a world which is correct. So I go and follow up with the scammers.
My name is Bill Buchanan. I want to claim the help for 12.5 million. Sorry, could you say that again?
Yes. Did you receive my details?
Yes, I received your details. And what is it to do with what is the
Fatos Buchanan,
inheritance that I've gained?
my cousin who died in
Yes.
plane crash. Was quite upset for a while.
My late client, who has passed away since 2007, he left an inheritance to a bank share, and there's no one to come and claim the fund. And the bank manager and all the bank directors know me as my late client representative here. So the instructor I received that I should present someone who they can release the money into his account, because we have a new government over here, and the new government is about to confiscate the fund. So that is the reason why I contacted you in order to present it to the bank as the beneficiary, so that it will enable them to release the fund to your account.
That's amazing. So I send you something, and you will put $12.5 million into my bank account, and then what happens after that?
Yes, what you have to do now is to provide all the above listed information of yours, which you help me to use to refer all the information
things are looking good for me. I'm definitely on a roll here. And yeah, so I sent them my passport ID. What do you mean that's not me? What do you mean that's not me? Okay, so they asked me for that, and then they sent me back. So I need to get all the details. And then I pay $950. But you say that's not me. What happened was that after a week, they had the cheek to say, that was fake. That was fake. We just realized it. So they sent me that everything was okay. And then after a week, they said, it's not okay. It's a fake bank. The bank really does exist. And you say, that person doesn't exist. Well, he does. I'm married to Karen Hayes, which is pretty good. It's pretty good. Well, yeah, as a fictional character. And there we go. There we go. So I wasn't lying at all. And what I'd love somebody to say this about me. Okay, what I love is it says, describes, he's the sort of grown up in the room. Oh, I've always wanted somebody to say that about me. I've never felt up to the fact of being a grown up, and I'm quite proud of never really having grown up and keeping that real interest in understanding. And then it says, the straight man for other people who certainly make it a more colourful place to watch. Isn't that fantastic? So that was my ID. That is truly Bill Buchanan, and he does really exist. So I'm going to do some crypto with you, okay? I know it's late, and I'm going to go through, because I'm an academic, I want to teach you something. And you probably know all this already, but let's go through some of the principles, okay? We start with symmetric encryption. Symmetric encryption, we use same key for Bob and Alex on either side. It's the workhorse of the industry, okay? When somebody says, what crypto are you using? You say, I'm using symmetric encryption. It's AES, that's what you're using. When you contact Google, you're using AES. Or Cha-Cha, that's another story. Google doesn't trust AES that much. Just in case it gets hacked, they have a crypto method called Cha-Cha. What a great name for it. It doesn't sound quite as good. I'm going to use Cha-Cha. That's great. So there's a secret key, and then we get asymmetric encryption, public key. Bob and Alice have two keys. This is the future. These guys are the core of identity on the internet. I have a private key, and then I have a public key. If I want to prove myself, I sign with my private key, and I prove with my public key. But what happens if I lose my private key? Basically, I lose all my bitcoins. So people think they've got this store of bitcoins on their computer. You go, where's my bitcoins? Well, they don't exist. Where are they? They don't exist. Show me them. Where folder are they in? They don't exist. You got a key pair. No, show me them. Where are they? How did they get in and grab them? They don't get on your computer. They go and grab your key pair from somewhere on the internet, and typically somebody that's not changed their name through I've been pawned. And they go and grab your private key, and then they show me the bitcoins, and I go, oh yeah, it's in this folder here. So there you go. And it's that magical key that provides us with identity and signing. And it's that key, public key isn't used for encryption per se, that symmetric key. This key, magic key, proves that Alice is Alice and Bob is Bob. But does anybody understand these three letters? And the short answer is no. We've built the internet up from PKI, and it's rubbish, absolute garbage. You can't even see your certificate anymore. And then there's hashing. So hopefully no one's got hash here. But hashing allows us to create a little fingerprint that you might need if you have been hashing something. It gives us this integrity to make sure that nothing has actually changed. Okay, so that's the three method, and because I'm an academic, I've got to do those methods. So then we come along to the lovely world of digital certificates, the rubbish world of digital certificates that nobody really understands. Okay, I'm going to quickly go over what happens when you connect to the internet. Noddy's Guide to Connecting to the Internet. Basically, I connect to Google. Google sends me the certificate that has the public key in there. I take a session key, a new key, an AES key. I then encrypt it with their public key. I send it back, and then they decrypt it with their private key. Everybody got that? That's how it works, kinda. Sometimes there's a bit of handshaking that goes on with random numbers and things like that. But that's the internet. That's what happens. And really, what happens if I lose that key? We're stuffed. Okay, if a major cloud provider loses the private key, such as Google or Microsoft or VeriSign, we're kind of stuffed. Happened recently when Adobe kind of lost their key under the mat somewhere. The big companies, I know one big company that shut down for several days and did hunt the piece of flash. So they had to make sure that they found everything. And the hotel, the dark hotel in the Far East, people were getting sent Adobe updates that were signed by 512-bit encryption keys, which were hacked keys. So anything that says 5112 with RSA, avoid it like the plague. Do you know who told us to use 512? Yeah, the camera's not on you, so you can see it. Who told us to use 5112? The CIA. Yeah, that's right. Yeah, so there was an export. This is high grade. I could go to jail just now. Hopefully I won't. I'm still in free space. I go with Californian law because all my YouTube videos are in California. So if someone's going to arrest me for things I said, then it's Californian law. But this is high grade export quality munitions. And it was up to the US to say that they limited the encryption keys to 512-bit. Okay, so let's look quickly at logs. So since we're in Napier's surroundings, does anybody know when I take two numbers like that, what the result of that is? What is it? X plus Y. Okay, and that's the basics of logs. So there's the basics there of some of the formulas, if you remember from school. And the core of what a lot of we do just now is this here. This is a prime number. This is a generator. Number 2 or 3 is typical. And then there's the result. And we have a magical number called x here. And the way this works is that if these numbers are large enough, it's almost impossible for me to guess what the value of x is, even though I give you the value of y. So that's the way that discrete logs work. So that's the first method of public key encryption, is to use that difficult equation. Unfortunately, when quantum computers come along, you might crack that. The second method, I'm going to get all weird now, hopefully I can draw this correctly, is that, let's redraw that one. Oops. That's probably even worse, but never mind. Elliptic curve, somebody came up with this curve, and I can pick a point here, I can pick a point there, and I draw a line between them. And I will always be able to cut the curve if I keep making a steeper and steeper curve as I go up. And this is the core of elliptic curve. Basically, if I have a point R here, R is equal to n times g. There's the point on the elliptic curve. And then if I have a gradient, I'm taking you all back to school again. Ugh. If I make n big enough, a really big number, really big gradient, then no computer in the world just now can actually work out what the value of n is, even though I give you the 2 points. Seems easy, because you just say there's a point, there's a point. But if this value is a massive value, It's really difficult when I give you those two values to work out the value of n. So that's how elliptic curve works. That's what the keys look like. If you're interested, they look a bit like that. And the other one that we have is RSA. So I won't bore you with what RSA does, but basically we get two prime numbers and we do some magic around them. And the problem with them is that we could be, this difficulty of factorizing two prime numbers might be cracked by quantum computers. But hardly anyone uses this method anymore. Why? Because we have crazy keys now of 4,096, and every week we've got to change our certificates because we need an even bigger amount. So RSA is kind of finished, and when we look at blockchain and things like that, it's all elliptic curve and discrete logs that are used now. So the methods are there. That's what a key looks like. If you've ever wanted to see an RSA key, there's an encryption key, there's your prime number, multiplication, there's your decryption key, and there's your n. That's what your keys actually look like. But there's a crazy method going around just now, and it's called homomorphic encryption. And this is going to get quite scary because data processors are going to be liable in GDPR. If I give you my data and you're crunching it and somebody finds out that data, you'll get pinpointed through GDPR. So there's a concept called homomorphic encryption that allows you to work on the crypto values. What a crazy idea. IBM have built a Z computer because they know that the next generation computers are crypto computers. And it basically does everything in crypto space, but really fast. So homomorphic encryption, you can do your maths. You can take your tax returns and you can do a calculation on them in crypto space. So you'll see where that takes us in a little minute. So I'm going to quickly go through blockchain. If you're interested, that's what it looks like. You get your WIF. You know what a WIF is? Well, your WIF is actually a base 58. Who knows the methodology that somebody came up with to create this? But basically, you have your private key, you use elliptic curve, and magically, that creates your public ID. Is it known? Yes, it is. Nothing is secret on blockchain. You can work out your ID from this public ID space. We sign things with a private key, and we prove ourselves with our public key. So that's the methods that we go through. And here's a transaction. That's what transaction looks like. Basically, all that Alice says is that I'm transferring from my account to Bob's account, and I'm signing it with my private key. But what if Alice overspends? So we've got to know, and the system's got to know how much she has in her account so that she doesn't spend more than she has. So Bob thinks he's got 1.2 million from a bank in Togo, but he's not. So Bitcoin needs to know. Bitcoin needs to know. Okay. So every 10 minutes or so, it's been getting a lot less. 1 meg, a dinky little block size of 1 meg gets filled up with all the transactions that happened in the world, and then they kind of run out of space, so they had to double it, and there was a big fight, but I think it's okay. So every so often, all the transactions go, and then they have to compute the hash for the new block, and they all compete against each other and consume more electricity than Ireland, was what I heard recently, but I think it's an even bigger country now. Eventually, your lights will go dim when the Bitcoin miners are mining. So they go ahead and they work out, and in Ethereum, we use this crypto hash. We use a gas value to stop people from over consuming on the blockchain. Okay, so we end up, and we've got the work that the miners have got to do is to come up with a hash, with a nonce, and they keep going, and they've all graphics cards are trying to get there, and then I think they come up with 14 zeros in front of it, and they go, yeah, we won, and they get 12.5 bitcoins. It's a lot of money. So there's still money in there for them. Okay, so that's what it looks like. You'll see it. At one time, there was 50 bitcoins for a reward, and this was block 0. So this was our friend earlier there. And then we see the hash for both the current one and the previous one in there. And it's all there, everything we can see. We can see the whole transaction for the block and every single transaction in the block. So for the police, that's okay, because they have ways of sending transactions and finding out who's who and so on. But that's not good for us, because people can find out when we're paying our gas bill and other things. Well, so we see our things there. So with smart contracts, Ethereum brings in the method of creating the smart contracts, and it builds on to Bitcoin, where we can compile some code, typically JavaScript, and then we use the Solidity compiler to create the binary code that runs on the blockchain. In this way, William Hill and the customer could actually have a contract that says, if Huddersfield win, then you get paid straight away, and we've been a bit silly. So I've got videos online if you want to have a look about creating Ethereum. We've not got time to look at them just now. But what we can end up with is the concept of a smart contract. So this is a smart contract for a marriage. We still go to a church and we still get a vicar to sign, and there's a ring involved, and people get drunk the night before and all that kind of thing. So with Ethereum, we can actually create a smart contract which will define exactly that somebody is getting married, and they can actually provide the proof that that's actually happened. So you can have a look online at this, but this is me setting up an Ethereum, sorry, I'm used to Ethereal for my Wireshark stuff. For Ethereum, this is me setting up, I compile it, and then I add it onto the blockchain, and then I have an address to it. I then run the code, and that enacts the smart code, the smart contract. And it's really the way that we need to move our services from here. So the problem that we have now is that everybody can see what's going on the blockchain. Can we have a way that we can take the processing off the blockchain but still keep the credibility of the transactions that are involved? So one method is to check that something is true. Does Bob really have enough money in his account, without actually looking at the amount of money he has in his account and all his transactions? So homomorphic encryption gives us the possibility of encrypting the values here and then creating an additive function. We then have a look, and we can check to see that Bob really has enough money in his account from there, because we can measure if the value is over 0. So the Hawk system is one where we can even get the processing off the block, and even the code doesn't know the values that we're passing to it. I don't know if you've listened to the nuance here, but you're passing values into a function, and the function has no clue what the values are. So it's working on the crypto values. So you might pass 3 values, 3, 5, and 10. The function does some coding, and it has no idea what the values are, and it returns back a value, which is the summation of the 3. So this allows you to move smart contracts off the blockchain and operate them, but still keep the credibility in there. So Zcash, I think Andrew introduced that. Zcash does that. It keeps a lot of cops awake at night. This is their worst nightmare. For money laundering, drug dealing, and so on, this is exactly what they don't want. There are ways that we can anonymize. There are coins that you can buy that will aggregate several people's transactions together and add them up and make a single transaction, so that you can't really tell the transactions that were involved. But this is the purest way possible, and it's with Zcash. But the problem with Zcash is that look at the amount of time it takes to actually create the zero knowledge proof. 40 seconds. 40 seconds with a really high grunt computer takes 40 seconds to create a zero knowledge proof on it. So something's got to change for that to happen. But the good thing is that once you've done it, it's really quick to verify through zero knowledge that it actually works. So that's one way. Hidden homomorphic encryption. With hidden homomorphic encryption, hopefully I've got a little example in here. We can take two values and we can operate on them, and we can find the result. So in this case, what I do is I encrypt X, I encrypt Y, I then multiply them together. That's the way discrete logs work. And then I can produce the encrypted value for the answer. So in this case, when I take 3 and 7 and encrypt them, and I do some maths here, the values add up in the end. But then if I take a value of 5, hopefully, it's not going to work, you can see that it ends up with an incorrect answer. So in this way, we can use homomorphic encryption to test a theory that something is right. Has Bob got 100 bitcoins in his account? We can take the values together and we can do some logic on them. The extension to this is with blind evaluation. And with blind evaluation, what we have is we can create functions that we can pass encrypted values in, and it will do some operation, return us back the result, and the function has no idea what we've passed to it. In a world of GDPR, that's perfect, because we can send our tax returns to the government, and they can aggregate them and never find out the result. So if you're interested, there's the maths behind it from there, but we can actually create our calculations, and it uses what's called a polynomial to be able to do it from there. And if you're interested in the Python code, it's there too. But with this, we should be able to prove, again, a certain calculation. So does A plus B equal the answer? In this case, it shouldn't be, hopefully, from there. Okay, so with these methods, we can actually create a blockchain method that will allow us to be able to keep things secret from both the data point of view and also from a processing point of view. And to me, that's the answer. If I want to, kids of the future go, what I need to go to the election place, sign stuff. I just want to do my mobile phone. I want to be sent something, my crypto, and I want to vote, and I want my vote to then be revealed at any given time. So for the future, that's likely to be the answer. So we're very lucky here to be working with Spiritus, and we're working here, as we've done for the last decade, to hopefully make some way forward in getting some trust infrastructure into health. So our recent survey showed the areas where blockchain could be moved forward. And you can see up here is the pioneers, the experimenters are around electronic health records and so on. But the opportunities are within blockchain. In these areas, we have a high chance of disrupting. The project that we're looking at just now is looking at the complete supply chain for health devices from their source manufacturing to the decommissioning. We want to follow a device through its whole history, and you can do wacky things like find out when something's been stolen. It happens, I know it sounds crazy, but it does happen in the NHS that things go missing and so on. So we hope to be tracking and using zero knowledge proof, because once you monitor a device, you're monitoring a person at the same time. So you really got to build that identity checking into it. So in the report that it gave, it took an infusion pump as an example. There can be many manufacturers involved, many people involved in calibrating and so on. If you find it's been in an error, then can you track exactly where the error actually happened? So they think there's significant savings, even in things like infusion pumps for the tracking. The other thing they identified is that only 1 in 5 medical devices ever touch a network. And you go, what? You can't be serious. And this is in the US, so you can imagine it's probably even less in the UK. And the reason is is that it's just not secure. We just don't trust putting an infusion pump on the internet in a hospital. I know it's crazy. They're probably sharing the same network as your TV and things like that. So the shared network. So really, something needs to change, that we need to network things in the future. And these are wacky things. These are pills that have got RFID tags in the container. So you can actually tell if somebody's got dementia, say, that they know that they're taking the right pills and so on. If you want, you can put the RFID into the pill. That's possible. And these are the next generation of inhalers. Smart inhalers connect through 5G. You can actually detect things. So there are opportunities for smart drugs and identifying pill containers. There's a 200 billion saving in a chain of custody just to watch equipment and to recall it whenever there's a problem. And then health insurance, especially in the US, who did what, who did that, who did wrong and stuff like that. Blockchain doesn't hide anything away. From there, you'll have a complete history of everything that happened in there. So, for me, I think we're building a new world of trust, and it's an amazing, fantastic world, and we can use cryptography or encryption to build it. But the tension just now is between security and privacy. I don't know if you feel it in the air, but the government ministers are forever saying backdoors and WhatsApp and all that kind of thing. And I know for a fact and they can't do it. So I went down to the House of Commons. I did go to the House of Commons. It's not as nice as the Scottish Parliament. And I talked about Bob and Alice to all these ministers, and they go, what? I go, public key, you know that, public key encryption. And I got the doll out and everything like that. No, didn't quite work. Went right over the heads. And they went ahead with that bill. Don't know if you know, but your ISP listens to everything that you do. You do know that, yeah? You did vote. You did, yeah? You got involved with that. So we said that if you're a terrorist, there's a very good chance that you're quite good at crypto anyway. And there's a very good chance you can write code and stuff like that. So, and anyway, it's all based on Signal, and Signal doesn't have any keys. They don't exist anywhere apart from here and here. They're not stored anywhere. So there's a tension between security and privacy, and we need to be protected as a society, but we also need to be protected from people spying on us. Then there's what goes on the chain and off the chain. We can't process fast enough. We can't put stuff on the chain fast enough. People like Spiritus have the whole back end, but they use the blockchain as their ledger to know what really did happen. That's the evidence. That's the concrete stuff. If you get the crypto working around that, you just have your whole infrastructure spinning off that. We think there's new public services. In 10 years' time, will you still be putting an X? Probably yes, in the box. And then there's zero knowledge proof that we think has got the opportunity. I thank you very much for listening to that. Hopefully you learnt one little bit of something, stuff, I'll call it. Crypto, encryption, call it what you want. Hopefully you learnt a bit from that. Thank you very much.
Questions?
I'm saving them from the beers. If they want questions, then it's fine.
Has anyone got any questions for Bella, for James?
I've got a question about Hyperledger. Have you had any experience with that, and what do you see as the future of that whole project?
We have any. Bob, do you want to comment on that one?
Yeah, sure. I mean, from our analysis, it looks like Hyperledger is really not quite ready for prime time yet, but tremendous potential for the industry, especially with the channels concept, to be able to address some of the concerns about keeping some information private from others. So yeah, it's got tremendous potential, particularly with the involvement of the Linux Foundation.
I highly recommend Spiritus. You network into an amazing US infrastructure. I think you network into some of the most prestigious universities in the world, and know some of the top people.
Well, there's also a reason why I'm here in Scotland, though. So, anyone who wants to approach me, Susie Rana, I think Spiritus, fine, thank you.
Yeah. So lots of journals. I know it's really boring. Journals are really good. publish papers if you're interested. I think you're on a really prestigious one. There's a lot of new ones coming up. We have special issues. Really great thing. I advise you to get together in a wee team and get together and write some research papers and get some peer review and try. Rubbish paper, can't write. Why is this guy an academic? You know that kind of thing. We can get used to that kind of thing. Did that answer your question?
Yeah, give me a good indicator, give me a pointer along the way. I'll go and speak to him after.
Yeah, great. Any other questions the spiritist can answer?
How the general question is like in whole blockchain ecosystem, how we can ensure that the device like which have a low computational power, for example, any.
I'll pay some money, thank you. Okay, good question. Okay, something we're looking at just now. An RFID device, a passive RFID device. You tell the electronic engineer that you want 10,000 transistors on the RFID tag that doesn't have a battery for crypto, and he'll tell you to get somewhere. You're getting 10 transistors, and that's it. And basically, you have no power. Okay, the power comes from the radio waves. Thank you for asking the question. The power comes from the radio wave, and the electronic engineer will say, "Get stuff. You're not going to do AES encryption 256 on my thing. I need stuff to happen." So there's lightweight cryptography. I've got some stuff on my website. If you want to have a look, I've got a paper coming out quite soon on it. There's Ella. There's help me out here. What was it? Cha-cha. RC4. It's been RC5. Sorry. There's a whole lot of new lightweight cryptography methods that use much smaller keys that have been used with RFID. Thank you for the question. I'll pay you later.
How much should we be worried by quantum computers and then being able to crack crypto?
I think we should be very worried about that. Basically, you've got to worry. There's a concept called, just trying to remember the ephemeral with encryption keys, which means that if I can hack your master key and it's not ephemeral, then I can hack all your communications that's ever happened. So always use an ephemeral key exchange so that even if one key is hacked, then all the other ones won't be hacked. But with public key, you just know what's going to happen. They'll stick on 4,000 bits or 12,000 bits or 16,000 bits for RSA, and they'll get over it. So I think it's still a long way off, but when it does happen, elliptic curve, RSA, discrete logarithms are finished. So I don't want to scare you, but
I'm just thinking about the time it's going to, I mean, look at the NHS example was from Windows XP. If we can forecast when that tipping point is going to be, when quantum computers will pose a risk, should we not be preparing for that now to prepare the slow-moving organisations?
Yeah, so I think companies are looking at that. Stream ciphers tend to be, the AESs and stream ciphers and the block ciphers are probably okay. It's the public key encryption signing that's going to cause a problem. So think ahead, get a research grant based on it, or sell your product because it's robust against quantum and create a business benefit.
Hi, so blockchain's great. We can sign things and prove that we've done something, but what would be really cool if we could encrypt something and send it to somebody else. So we're talking about PKI, you've got another public key to send it. So my question is, have you looked at things like the 3-pass protocol? And do you think those kind of things are secure?
Yeah, so we think that things like the 3-pass protocol, that companies shouldn't be storing things like passwords anymore. In fact, the citizen should be generating their own password or doing something and then passing the evidence that they know it. It's just a crazy world that we have hashed passwords. My ISP forces me to do 8 to 10. I don't know if you know who that is. 8 to 10 characters, and where question 1 is a good password. And I saw a tweet that says, we do that because we like to keep things nice and simple for our users. What did you just say there? You just said that on Twitter. You just said that on Twitter, that you think simplicity is better than security. Just wait till May next year, and I bet you that tweet isn't there anymore. so there are crypto methods around that are really good, and if you need to hash, then things like bcrypt are the slowest thing possible. Crunch the CPU. They had I should have brought a cloud pet along. My grandson loves these little cloud pet to speak to it. Cloud pet used bcrypt. They got hacked. I think it was 2 million voice messages between the parents and the child through the teddy bear, or on the S3 cloud somewhere. It could be found by Shodan. And they were using bcrypt, good on them, well done, but they were using 4-character passwords that kids could use. And even with bcrypt, even with your fridge, you could probably crack that. 4-character passwords, oh my god. You could probably manually do it yourself. So we think the back end needs to be secure, and we need to be thinking about all the protocols around it.
Sorry, I've got another one. So you spoke about homomorphic encryption.
Yeah.
So that's when something's already encrypted and then you can modify it without decrypting it, right?
That's right.
So I was looking at things like that, and you've got these great algorithms that can swap a bit in, say, 30 minutes or stuff like that.
Yeah.
And they're trying to work on something that's like usable. And by usable, I mean like less than. I mean, how long do you think that's going to take until we can see it and use it?
Yeah, that's a difficult question. I know that IBM have got out of computers and are building mainframes. Again, they're always good at that. They're building big crypto machines that can do these things. Yeah, GPUs, you have 4,000 cores in there that can do crypto like anything. So I think the grunt is there. You can get any amount of computing power that you really want. If it's between 4% of global turnover, you can get fined. And me buying an NVIDIA graphics card, you tell your CEO, you pay $500 for a GPU, or you go to jail. You get that. Or your shareholding is going to go right down if you don't buy me a graphics card. To do crypto, of course. So I think that computing power, but you need to understand the risks that are involved all the time. If it's your SSH keys for your Amazon cloud account, then you've got to have multi-factor authentication on those ones, and you've got to have the best crypto possible. The hack that happened on Enigma, they got into the website, changed the web pages, they got into the Slack, and they can see all the contacts. Watch if you're using Slack, by the way, using WhatsApp. And what was the other thing? Oh yeah, I told you about that. But the password of the guy. So if you're a CEO of a kind of a big cryptocurrency thing, use a really big long thing, and then have multi-factor with your voice and your face and your body odor. Honestly, it's possible. If you're going to ask me a body odor,
with all this mathematical encryption around and the search for the perfect cryptographic process, if I can put it that way, on the one hand, and every major government on the planet not really wanting to do that on the other hand, where are we? Where are we now in the next 2 or 3 years, 4 or 5 years?
Where are we like to be?
Where are we?
So
can we encrypt?
So Google sent me an email that says, if you don't by the 20th of October, change this one page to make it HTTPS, we're going to say that you're insecure. So if a government sent me a letter to say that, I go, well, that's fine. Dear occupier, your website isn't very good. If Google say, we're going to mark your site as not being secure. See that web browser that says your thing? If you have an input tag there, if it doesn't say HTTPS, we're going to mark it. Chrome, you know what Chrome now has? 60 to 70% Internet Explorer. Does anybody use Internet Explorer? Come on, you shall be saved. Come down to front. Anybody use Internet Explorer here? Oh, good. That's good. Occasionally. I'm an occasional user of Internet Explorer. when the kids are out of the room, I just Internet Explorer. How many of you look at it? What's it called now? Edge. Okay, that was a good move. So when Google said that the world needs to be HTTPS, then the world shall be HTTPS. So the industry is driving, and the politicians are driving another car. It's a different car. And I know the way Dell Secure Works reckons that within 5 years, 99% of all traffic will be HTTPS. So it's going to happen, and there's nothing we can do about it. GDPR will be the biggest wake-up call ever. Okay, the first hack that shows you've not encrypted your usernames and passwords, then you'll be put and you can be fined and so on. So I think the computing power is there, and it's not a major problem. The homomorphic will take a lot longer, but researchers are working on it just now. So I mean, I feel that we're all in a playground. It's like being a child again. I feel as a researcher, I'm in a playground. I can do command line stuff again. I can do a little bit of JavaScript. And I think that's the wonderful thing just now, is that we all feel that we're playing. And it's not big companies anymore. I'm sorry if you're in a big company. You're great, but there's lots of great little companies that kind of say, here we go, here's our opportunity to tip up the car. So I think it's going to happen, and that's what our research is all about, and that's what kind of makes it fun.
All encryption
by
is a
default.
waste of time.
Encryption by default will be the only way to go. Everything will be decrypted in memory. In memory is the biggest loophole just now, because the code pops itself back up. And I think in the future you'll be seeing encryption in the memory of the machine. So even if I took the chip off and examined the RAM, the memory, I can still not see any of the variables in the code and so on. So that's the way that things are going.
So what's your take on secure enclaves then, right?
Secure enclaves? What was that?
Secure enclaves, right?
Yeah. So I think that needs to happen, and I think that makes security simpler. If you actually define that you can have a space that you can make sure is trusted, there are only certain ways into it, there's strict controls. I think access control is probably the weakest area in industry just now, and I don't think many companies, my email system doesn't have multi-factor. The passive reset is still with knowledge base. I've put the wrong answer. Does anybody else do that? Is it just me? Put the wrong answer to the question, who's your favourite football team? Everybody know who my favourite football team is? Ours. Well done. Used to be Falkirk. That's really bad. Isn't that? That's the worst thing that you can do. I lived in Edinburgh for longer, but that kind of worries. So I think companies need to understand the whole architecture. Any other questions?
Yeah. Can you verify the British Empire exists?
British Empire. Okay. I need to think about that one. I think it does. I think we've got the Falklands. I say we, so I don't know what I mean by we. Me. I think we've got the Falklands. Is that right? We've got Australia.
Pitcairn Islands.
We've got Greece.
No, Pitcairn Islands.
What is that?
The Pitcairn Island.
The Pitcairn Islands. See there, we've got Pitcairn Islands. Is that enough proof?
That's for you, really. Because
with homomorphic encryption, I'm sure I could run a bit of Python script and prove that the British Empire does exist, and pass variables like, what was it? The Peaky Islands?
Pitcairn.
This is where the survivors from the bounty set home and they live there.
So there you go. You never thought that you'd go to a blockchain meeting and end up about the Peaky Islands, did you? Does that answer your question?
Yes, it does.
I'll send me an email and I'll send you 0 knowledge proof. Any other Peakin related British Empire questions? Do you know what the British Empire actually means? They don't have it anymore. Do you have you heard? Yeah. It does exist, doesn't it? In history books somewhere. No, if there's no other questions, then I'm holding you up from your beer. Thanks very much for that.
Thanks very much, Bill, again, and thanks, James. Thanks, everyone, for being here. We've got the glass room where you came from earlier. We can go back there. We've got to 9 o'clock. I think that's right. So maybe some cold pizza to finish off and hopefully a few beers. So thanks again, everyone, and we'll see you all again next month. Thank you.